So I'd like to take some time and practice looking at actual control panels that are in the field. This is an example control panel from Puerto Rico, and we're going to step through this control panel learning to identify the different subsystems. All right? So when I say subsystems, again, I'm talking about those three sides of a control panel. We got the power source, incoming power. We have the contactor, the actual switch. Sometimes that's going to be referred to as a motor starter. And we also are going to have the control circuit, the thing that is driving the logic, telling that contactor when it should be open and when it should be closed. So let's go back to the system and take a look at this. Can you identify for me where the incoming power is in this system? Okay, so the incoming power is right there. If I wanted to add a little bit more detail, I believe incoming power is actually coming in through that little piece of conduit into here. But this, it looks just like a breaker box, right? It is. You're almost always going to have a breaker be the first thing that your incoming power lands on. And it should be that way, okay? Because you need to protect everything inside your box from surges and overcurrent. And also, you need to be able to turn off the power to the rest of your box so you can work in it safely. So if you're going to work in these boxes, you have to be able to identify where incoming power is coming from. All right, next, where is the AC contactor? And actually, let me go back quite a number of slides here real quick. I want to take a look at this contactor again. And a characteristic feature of this contactor is going to be that right in the center is almost always going to be a different plastic that's kind of in a different insert and it's able to move. So the best way to identify a contactor is by looking for that. All right, so we're looking through this control panel for the contactor. We're looking for the center little insert that can move back and forth. And it's difficult to see here in this photo, but we are looking right here. This is our contactor. Now you see that I'm also including this component above the contactor. That's because that is a circuit breaker. And it's a very standard assembly to have your circuit breaker directly above, directly before your contactor. Even if you have a circuit breaker for your main system, right before your contactor, you should have its own circuit breaker. Okay? So now, where is the control circuit on this panel? It's right here. So when I look at this, I see there's a lot of stuff going on. One way you can identify the control circuit is typically, not always, it's going to have smaller wires. You can see that these wires over here are much smaller than these wires. Now I want to say as a warning, just because a wire is small does not mean that it's not dangerous. It could still be at the same voltages as the large wires. When I look at this control circuit, I see some relays. There's probably some time delay relays. This looks like a timer, might be telling us the time of day. This looks like a voltage monitor. And this looks like status indication and also some operator buttons. Okay? So these are the three sides, the three components of the control panel. Let's move on to another box here. This is a nice, clean, looks like a well-designed box. We open this up and we want to make sure that we can safely work inside of here. So we need to find out where's the incoming power. And it's right there. This one's a little hard to identify, but these are fuses. So this doesn't look like it has a breaker for the whole system right here, but it's got fuses protecting everything downstream of here. And oftentimes, very well-made boxes like this, it's going to have the power coming in the top left. That's a traditional location for the power to be coming into your system. So where now are the contactors in this system? All right, we have our contactors right there with circuit breakers again. So we have, looks like 2 contactors. See that plastic insert, different plastic, it's able to move. And right above it, we have circuit breakers. So it looks like this control system is controlling 2 different pumps. Now, if we were to move on, and where is the control circuit located? Right there, we've got some that is located in the main box, and then others that's located on the door. These are different push buttons or switches that the operator can access without having to expose himself to dangerous electricity by opening this door. Now there's actually a few other components in here that are worth mentioning. Another safety component is this right here. This is a switch, and you can't see it in this photo, but there's a long rod that extends on it right here towards us as we're looking at it. And that rod actually goes into the door right here. And there's a big switch on the back side that forces the operator, before they can open this panel, to turn off this component right here, which de-energizes the system, making it safe. Also down here, this is a power distribution bar. This is simply taking our incoming power and giving it out to all the different components that need to be powered. Additionally, I want to point out that below these these fuses, it looks like we have a transformer, okay? Many times these pumps are operating on high voltages, 480 volts or more. But our control system, we don't want 480 volts, we want 110 volts. Something smaller that's a little bit safer for humans to interact with. So this transformer is going to take the high voltage and step it down to the control system voltage. Here's another system. On here, where is the incoming power? Incoming power is located right here. You can see the incoming power, it has a breaker so that we can turn off the power to the whole system, and it's protecting it from any type of short circuit conditions. Now, where is the contactor? There's our contactor and overcurrent protector. This is a little bit harder to see than the previous ones, but right there is that plastic insert that's going to push in and out, just like the one you might be playing with. And it's going to turn on and off the pump. Another feature, I said it has an OCP, Overcurrent Protector. And that is right here, and that is measuring the current on each line that's going over to the pump. And if it senses too much current or an imbalance of current, it's going to send a signal to the contactor to open, to turn off the pump. Now I have not, you could say that that is a part of the control circuit because it's sensing some type of environmental input and then relaying a signal to the contactor, and the contactor is what disconnects the pump. But I've included it here as part of the contactor assembly because it is almost always done that way, and it's going to be directly beneath the contactor. So now, I ask you guys to find where is the control circuit on this. Right down there on the bottom. Looks like we have a couple more breakers, obviously smaller breakers than the main breaker. But it's good to install these breakers on your control circuit because you also want to protect your control circuit. All right. This is another relay. Might be controlled on another switch somewhere else. And then we have a timer. They probably only run this pump during certain times of the day. So they use this timer to control maybe this relay controlling this contactor. A couple other items that we should point out here is going to be this right here. This is another transformer. So this system is a 480 volt system, but this timer doesn't want 480 volts, it wants 110 volts. So this is stepping down the power to what your control system wants. Also here, this is a sub monitor, as it says, and it is monitoring the current on each of those lines, and it appears it has some type of remote monitoring. See that Ethernet cable? And they're probably monitoring it elsewhere or recording its performance. So I mentioned having a contactor with an overload protection, an OCP, Overcurrent Protector. Those oftentimes are even bought together and they physically mate with each other. That, as a unit, is called a motor starter, okay? And you should always see those together. All right, what is this control panel a photo of? It's our beloved CU200, right? Now we're looking at this, maybe we're feeling confident after that last control panel, thinking we could identify everything. Now we look at this and go, oh boy. Well, it's difficult to identify the components in this control panel because it's based on a printed circuit board, a PCB. But even though it's difficult to identify the actual individual pieces, we still know that we have the three sides of our system. We have incoming power, we have our control, and we have our outgoing power. So that's our CU200. All right, one last control panel to look at. This time I'm going to show you images of particular items there, and I need you to tell me what they are. So, first we're going to zoom in up at the top right here. What is that? That is our voltage monitor. It is a part of the control system. Voltage monitors typically are a little more complicated looking than other things, but basically we have each line of power, L1, 2, and 3, coming in to our system. We set these dials to whatever thresholds we want to act upon. And then this is the output. It either opens or closes based on if the voltage is good or bad. All right, next we are going to zoom in the bottom left right here, okay? So, that is what? That is our motor starter or our contactor. So what is this? This is our contactor. How do I know that? This little plastic insert, it moves. And then what's this right below it? That's our overcurrent protector. It's measuring the current coming in and out of that, and then it's telling the starter whether there's a problem or not. All right, now we're going to take a look up in the top right here. What do we think this component is? That's our power input and our breaker, okay? So that's where our grid power is coming in on the top, and then it's coming out on the bottom, going to our different components. We have a circuit breaker to protect us from overcurrent on the system as a whole. Okay, now we're going to zoom in right here. What is this stuff? This is part of our control circuit. So this is our voltage monitor, if you remember up there. Now this is a relay. And these are circuit breakers that are protecting our different components of our control circuit. All right, that is all I have for this section. So again, if you have questions, please reach out to a team member you have in your office there, or reach out to us here in Charleston. We love questions. We definitely do not have all the answers, but we'd love to spend some time working with you, working together to find out those answers. So thanks for joining.